Hi, and today I'm going to talk about forces in equilibrium, and I'm going to show you how to use vector analysis to work out various angles dependent on the various forces that might be taking place. And to demonstrate this, I've got this pulley system where I have three masses hanging, and they are using pulleys so that this particular mass over here is suspended due to the fact that there are three forces acting on it, but they are in equilibrium. Clearly, one force is its own weight, vertically downwards. One is a force along this string over here. The tension is provided by this weight over here, and likewise on this side. And the actual angle that exists here is determined by each of the individual forces acting. So if I were to add a particular weight on this side, in other words, I increase the weight on this side, you can see that the angle changes. This angle here clearly is no longer equal to this angle over on this side. If I were to add another weight, but this stage I add it over here, again, we're going to see a different effect. As you can see, they both get pulled up, the tensions here are changing, the angle here changes, and again, the actual values here are determined by the weights that are being exerted at these 3 points. So how do you get to work out how this all works? Well, that's through vector analysis, and that's what we're here to do.
So let's start looking at a fairly simple situation where I have three masses here hanging, and I'm going to make these masses specific values. I'm going to make this 4 newtons over here, 4 newtons over here, and 5 newtons in the middle. The reason I'm doing that is I'm going to use this as our simple example. I'm going to get progressively a little bit more difficult. And as I stated, this point here is in equilibrium, so Newton's first law applies. As a result, the three forces that are applied to this particular point add up to 0. So we have the tension that runs in this direction, and we're going to call that T2, and that's the same tension that is sitting over here, which is T2. And likewise on this side, I have tension 1 and tension 1 up here. And because all these are equilibrium, if this is 4 newtons acting down, then that's going to be equal to 4 newtons here. Similarly, over here, this tension 1 also ends up being 4 newtons. And so what we have now is, with this last one, of course, equaling 5 newtons down here, we have here a point experiencing 4 newtons this way, 4 newtons this way, and 5 newtons this way. And they're going to add up so that the total equals 0. So T1 plus T2 plus 5 has to equal 0. But of course, this is a vector. So let's draw this. So I have my vector that's downwards, and it's going to be equal to 5. I'm just going to drop the units for the moment. And then I'm going to have a vector that's heading in this direction, which is going to be my 4. And I'm going to have a vector across this way, and that's also going to be equal to 4. And as you see, we're drawing now a triangle. These vectors add up to 0. And because I've chosen 4 on both sides, you can see I have a nice isosceles triangle. Now that allows us to work out, for example, what this angle is in this situation, or at this angle or this angle. It doesn't really matter, because this angle here is basically the sum of these two halves, and those two halves happen to be equal to this angle here and this angle here, and they're actually exactly the same. So how do we solve this? Well, this is just a vector problem. So we know that these two angles are equal. So I only need to work out this angle here. And let's call this alpha. And if I have this alpha here, you can use cosine rule to solve this. So cosine rule, of course, says c squared is equal to a squared plus b squared minus 2ab cos c. And I always encourage my students to write down the formula first before substituting things in. So now substitute things in, you get 4 squared is equal to 5 squared plus 4 squared minus 2 multiplied by 5 multiplied by 4 multiplied by the cosine of c. I can now rearrange this. You can see I've got 4 squared over here and 4 squared over here. I can actually cancel those out. And I end up getting, if you rearrange it, I get getting cos of c is equal to negative 5 squared over negative, if you multiply that, negative 40. Of course, the negatives cancel out, so I'm going to get 25 over 40, simplified, of course, that is equal to 5 over 8. And my angle ends up being 51.3 degrees. And so the combined angle here is simply double that if you wanted to use that as well. Now, can I solve this not using a vector diagram, but can I solve this by looking at the concept of components? And the answer to that is yes, you can. Now, with components analysis, you need to understand that whatever's happening horizontally cancels out and what is happening vertically cancels out. So in other words, if I look at the x component of this point and the x component of this point, they're going to be equal and opposite because I'm getting no horizontal motion, no horizontal acceleration in this direction. Similarly, if I look at the vertical component of this guy, and the vertical component of this one over here cancels out with the vertical component of this one. And of course, there is only a vertical component here. So if we break that down and write that out, we get this. So let's look at the x component. I have T2, and I want this component based on this angle. Now, that's actually the sine component. So what we have here is sine alpha. Now, some of you are saying, hey, is that supposed to be cos? Well, that's if you're looking specifically at this angle, but I've been looking at this angle here. So there's this sine. I now add, of course, the other one that has a horizontal component, and so that's going to be T1, and similarly, this is going to also be sine alpha. Remember, these are equal angles because we've made these forces equal. And of course, that's negative, and that equals 0. Well, that's pretty obvious. It's the same values. Let's have a look, though, at what we do in the y component. So let's look at y. We have the T2, we're going upwards, of cos alpha plus T1 of cos of alpha. Remember, there are two aspects, plus the negative, this one's heading in the opposite direction, 5 equals 0. So if I rearrange that, I get 5 is equal to 2 times T2 cos alpha. I've noticed I've done 2 times there, but remember that the same forces. So we know that this is going to be equal to 4. So now I have 5 is equal to 8 cos alpha. And that means cos alpha is equal to 5 over 8. And that's going to give us the same value that we had before. That is, alpha is equal to 51.3 degrees. So you can see we can analyze this using vector analysis, or we can analyze this looking at components. Now this is a fairly simple one. So let's look at a more complex one. So let's say I have here a situation where I have 3 masses hanging, and clearly the angles that we have in here are different. And I'm going to draw a horizontal line so that I can look at various aspects of the angle here. And let's say I know that this angle here is 22, and I know that this angle here is 49, and so a combined angle here of 71 degrees. And I want to know what mass here would cause this angle to place if I place 4 newtons on this side and 2 newtons on this side. So what is this one right here? Well, again, we can look this in one of 2 ways. We can look at a vector way, or we can look at components way. So if we did this as a vector way, we now can draw our vector. So we have, of course, T2 in this direction. We have T1 in this direction, and we know that this is going to be equal to 4, and this is going to be equal to 2. And this vector down here is going to be, of course, unknown. Now we draw these vectors, and so we've got our vector that is downwards, which is going to be our unknown, and we're going to simply call it y. Then we have a vector in this direction over here, and this is going to be equal to 2. And then we have a vector that's drawn in this case, and that's going to equal to 4. Now this is not properly drawn to scale, but you get the idea. Now we know that the angle here is 22 and 49. So we know that this is going to be 49 over here. And if this here is 22, then this angle in this section is also equal to 22 because of alternate. So therefore we know that this angle here is equal to 22. Now, it's now relatively easy to work out y, because since we have y on this side and we have these two angles known, you can see that the remaining angle there can be worked out. And the remaining angle is going to be simply 180 minus those two angles, and that's 109. So now you can see all I need to do is use cosine rule. And when you calculate that out, you get 25.2, and therefore y is equal to the square root, which is approximately 5 newtons. If I want to do this by components, again, I can need to look at the horizontal and the vertical components. Now, I won't look at the horizontal components in this case because this guy has no horizontal component, so it will be a moot point. So we're only going to look at the vertical components here. To do that, all I need to do is to say, okay, I've got y, and of course that's in the negative direction, plus t1. Now this component here is the cosine component, and so it's t1 cosine 22 plus t2 cosine 49, and you can see that's going to equal 0 because it's not moving vertically. So now I have an equation for y. Y is equal to 4 cosine 22. T2, of course, is 2 cosine 49. Again, you're going to get 5 as a result. Again, components or vector analysis allows you to work this out. And now we have a slightly more complex example where I want to work out the total angle here, knowing that these three masses have specific values. And so I'm going to have 6 newtons on this case, I'm going to have 5 newtons on this case, and I'm going to have, again, 6 newtons over here. Because these two are different, these two angles, alpha and beta, are not identical. So we can solve this, of course, in one of two ways. We can solve this using vector analysis, or we could solve this by components. And for this example, I want to look at components first and to show you a slight problem that may encounter. Before we start, let's just make sure we label everything. We have 6 newtons acting down, we have 5 newtons acting this way, and we have 6 newtons here. And if we now look at the components, we can work out, first of all, the x component. So let's have a look at the x direction only. And so remember, we're dealing with this angle here. So we have 5 sine of angle B plus the negative of 6 sine of alpha equals 0. And so we get an equation here where I have two unknowns, alpha and beta. Now let's have a look at the y components. I have 5 cosine beta plus 6 cosine alpha minus 6, it's a vertical, is equal to 0. I could write this as 5 cosine beta plus 6 cosine alpha equals 6. So I have now 2 equations and 2 unknowns, and I have to solve for alpha and beta. This is getting a little bit complex mathematically. Now, I will show you how to solve this at the very end of the video. So once I finish with the explanation with this particular problem, stay tuned if you want to watch how I solve this using simultaneous equations. So let's have a look at in terms of vector analysis. Now I have my 6 value down. Of course, I have my 5 value across this way, and I have my 6 value here. Again, if you look at the angles, the angle that I have here is alpha, and the angle I have here is beta. You can now see, of course, I can simply apply cosine rule twice for angle alpha. If I'm going to do this for the beta, and again, you can rearrange this yourself, and I'm going to get an angle 65.4. So my total angle, if this is 65.4 and this is 49.2, my total angle is going to be approximately 115 degrees. That's how you solve situations where forces are in equilibrium. You simply apply Newton's first law to your situation and you can solve it either by vector analysis or by components. Now, of course, if you want to watch me solve this by simultaneous equations, continue watching. But otherwise, bye for now. So first, let's take these two equations over here and on a separate page, so we have a little bit more space to work with. And here, of course, we have our x component equation, and here we have our y component equation. So let's start first by looking at this particular equation right here. If I rearrange this, that I get 5 sine beta equals 6 sine alpha. Again, if I clean that up, you can see that the sine of beta is equal to 6 sine alpha over 5. Now, if I now draw a triangle and I make this over here equal to beta, then I have 6 sine alpha over here and 5 over here. And of course, I can then work out what this is. This ends up being the square root of 5 squared minus 36 sine squared alpha. Our second equation says this. It says 6 minus 5 cosine beta minus 6 cosine alpha equals 0. But I now have a relationship here of cosine beta with referred to alpha. So I have 6 minus 5 multiplied by, now the cosine of beta in this case is equal to the square root of 5 squared minus 36 sine squared alpha all over 5 minus 6 cosine alpha. And of course that equals 0. So this 5 cancels out with this 5, and sine squared alpha is 1 minus cos squared alpha. So now we have 6 minus the square root of 25 minus 36 outside of 1 minus cos squared alpha minus 6 cos alpha, and that is equal to 0. I'm now going to get the square by itself. So I've got 6 minus 6 cosine alpha is equal to the square root of 25 minus 36 outside of 1 minus cos squared alpha. Again, we can clean this up. 36 cos squared alpha minus 11. Now I'm going to square both sides. So this squared, this is simply a minus b all squared. So that of course becomes a squared minus 2ab plus b squared. So I'm going to get 36 minus 72 cosine alpha plus 36 cos squared alpha is equal to 36 cos squared alpha minus 11. You can see what's going to happen here. These two are going to cancel out. And what I'm going to get now is 36 plus 11 is equal to 72 cosine alpha. So cosine alpha ends up being equal to 36 plus 11 is 47 over 72. And when you work alpha out, alpha ends up being 49.2 degrees. If we check our answers from back before, that was alpha over here. Of course, all I now need to do is substitute in that into one of these equations, and of course I'm going to choose this equation. So 5 multiplied by the cosine of beta plus 6 multiplied by the cosine of alpha, which we already know is equal to 47 over 72, we don't need to actually substitute it in, is going to equal to 6. If I rearrange that, I'm going to get a cosine beta that is equal to 6 minus 6 multiplied by 47 over 72 all over 5, which boils down to 5 over 12, giving us a beta equaling 65.4. And of course, those two will add up to our 115. A little bit complex, but clearly doable in the long run. Hope that's helped you. Bye for now.